Hi everybody, welcome to another WAES Tech Talk. My name is Gerald Pruijsen, I'm Managing Director of WAES. Today we're going to talk about JVM and more in detail about JVM technologies. So for the first presentation, I'm going to invite Igor to the stage, and Igor is going to talk more about Kotlin and DSLs. And DSLs is probably something you use in your projects, but you're not fully aware of it. So we're going to dive into more detail now. So, Igor, welcome. The floor is yours.
Hey, welcome everybody. So I will start talking about Kotlin DSLs. Well, before I start presenting you all, the first thing I will do is talk about myself a little bit. So who I am? I am Igor Alves. I like to do things like eat and barbecue, do bouldering, play guitar, and spend time with friends. Yeah, I liked it a lot. And I joined WAES months ago, so on my second, and I currently work in a KLM project. So yeah, I love airplane. It's awesome to me, this project. And before I read the summary here, in this presentation, we'll get more conceptual about cells. I want to so deep because there are too many concepts of cells, and also you will probably spend a lot of time to know what all the features. So the first thing I will show you is what is a DSL, the concepts, the examples of DSL, why I choose Kotlin to that, and what features that Kotlin. The DSL's creation process. I will show basically an example in a real case in a code, and then I will also explain about the risks for you. So before we start, I would like you all to read this QR code in front of your screen or enter to this website and put the code, because I asked you a question about if you have worked with DSLs already in your project. If you work that somehow, enter that site and then let's see the results. I will put on the screen for you all. Yeah, so that are the results. Well, 2 people never used, 1 more than taking a shower. So it seems like we'll have an expert here. Yeah, let's wait a little bit. 1 just on Fridays. Yeah. Okay. Yeah, you see, most of people never used the DSLs in project, so it would be good to show you all about the features. Nice. Just a second. Yes. Let's continue. So what is a DSL? Good. Before I start talking about DSL, the first thing I will do is show you about 2 types of language we have in IT. We have general purpose language and domain-specific language. So what are general purpose languages? A GPL is a language broadly applicable across domains. It lacks specialized features for a particular domain. So I put a planet in the screen. And why I choose a planet? Because using a planet, we can see that a general purpose, it talks about around everything we can imagine. So you have language purpose, the general purpose language, which are Java, Kotlin. You have Python for that, because you can do a lot of things with this language. You don't have a limit. You don't have a strict wall in front of you. So you have the flexibility to build what you want. But a problem of it is because with a general purpose language, maybe you get some hard things to do, which is something simple, which is something specific. I'll get to you like an example. So, for instance, imagine that you want to let me think. Imagine that you want to build a drugstore. Yeah, so you have a planet and you want to build a drugstore inside this planet. Well, it's hard because you don't know about the medicine inside the drugstore. You don't know about the workers, how will they work, what should they wear. So you have a lot of variables inside that, so it makes hard for you to build a drugstore. So if you have the instructions to create the drugstore, it will be easier because you just have to tell the system or your planet that you want to build a drugstore. So this is what a domain-specific language talk about. So a DSL is a language created in a particular domain. Is optimized to solve specific problems. And why it is easy? Because if you have just one domain to focus about, like a drugstore in our example, okay, so you have a business domain to take care. And then with a DSL, also you use a declarative programming based. And for those who doesn't know about declarative programming based, declarative way, you say to the system what you want to be performed instead of saying how. So it's easier. For instance, if I want to ask for someone, oh, give me the food, it's better than teach someone how to give the food for someone. And I will show some examples about DSL that are currently in the market. Yes, I will show later the examples. So yeah, inside the DSL definitions, we have two types of DSLs. We have externals and internals. The externals are independent. So this kind of language have their interpreter and compiler. We have some examples like CSS, XML, and we have internal DSLs. For internal DSLs, you need a host language because you build like a mini language inside all the application context. So if I want to build an internal DSL, I need to build within a Java, a Kotlin, or a Python project. And these are the examples. So for external DSLs, I have CSS3, SQL, the language, not the technology, because in SQL you have the queries. So if you want to query like data in database, you just tell the system that you want the data. Select everything from. You don't need to build all the unnecessary things to get the data. And Puppet as well, we have the declarative programming inside the technology, not the entire one. But for instance, Puppet, you use that to declare what machine you want to deliver inside the technology. And Gherkin as well is the same thing, and you use that for Cucumber technology. For internal DSLs, you have Mockito, because Mockito runs inside a host language, which is Java, Kotlin, and JVM parent here. So Mockito you use to facilitate all the tests behaviors. And Waver is a new functional library that now is being famous in Java. So it also has the DSLs to construct a lot of things. And I put like jQuery and React, but jQuery and React are not the DSLs. The language they have inside are DSLs because they facilitate all the process you need to finish your building. And jQuery is a technology. It's running under the JavaScript environment. So what are the benefits of using a DSL right now? Well, if I want to use a DSL, my code becomes more efficient because I can get rid of grunt and repetitive work. And also, if I don't have the grunt work like the loop, the for loop repetitions, the if-else cases, so I have to focus only in the problem, so it decreases all the maintainability inside. And if I have the focus, it means that I can achieve a clear thinking because I can separate what is essential for my code, the business, and what is not essential, the incidental complexity inside that. And if I have context, also, I have interpretation being fluid. For instance, if I ask JP to pass me a fork, well, pass me a fork, JP. He will understand probably that I will be in a table, in a dinner table, asking for a fork. But if I don't have DSL, if I don't have context, it's strange to ask for a fork because we have a lot of fork context in the planet. You have fork in a restaurant, you have fork in a market, you have a lot of forks, so it's hard to get things in the way you want. So, and why Kotlin? Why I choose Kotlin to show you this, why they are special for DSLs. Well, Kotlin is now for its readability. It means we have a clear and a very concise syntax. With Kotlin, you have a lot of functional capabilities that are made by default the language. And we don't have conflicts with the regular code. It means you can mix that up. You can mix the regular code, the Kotlin code, with the DSL without problems because they work independently. In the Kotlin is totally DSL ready, but Java isn't yet. So for Java, if you want to make functional programming, you have to add a lot of libraries, and most of these libraries are experimental right now. So if you want a fluent code, a readable code, Kotlin is the best option currently. I will explain about the Kotlin features right now. So as you see in your screen right now, you see a lot of important features. I cannot talk about every feature because there are too much. But these three, marked in blue, I will explain a lot because they are the required if you want to construct a DSL. But if you want to build a complete DSL with all the features, I recommend you all to take a screenshot of this screen right now, and then search for it later because there are like additional complements you can put in your project later. Well, so starting about the marked blue features, the first one, now entering the code, the high order functions basically are functions that receives functions as parameters. So it's hard to think how a function can be inside another function. But if you think in a function like a variable, you will see that you can store a function in a variable as well. And I will show you a practical example on it. So imagine that in this code, let me take my laser. Okay, now. Here you see my task inside a function. And this my task data type is also a function for those who understand the Kotlin syntax. So it is an empty function without parameters that return a string. And this is awesome because you can manipulate the my task variable. You can store that in a different function. You can return that. You can change the data type. You can do a lot of things like a common string or a common integer. And what I'm doing here is calling this function inside another function. So this is a kind of interoperability. It's awesome. And why I do it, I'll show later. The next are the extension functions. So extension functions, basically, you can have the ability to add functionality to any class, even the classes that aren't, that cannot be modified. So basically, you see now in this main function a print where I give my name, and I have a function here with surname first. This function proposes to invert my surname with my first name, and I don't have this function in string. So what I did in above is basically add a method after the data type. It means I'm adding more functionality to a class that cannot be modified. This is just an example, but don't do it at home because Spring cannot be modified by default because there's a purpose under it. But if you have your class and you want to add a DSL, it's better to create extension functions because you can split your regular code from the DSL, and this is awesome. And if you mix the higher order functions with extension functions, you can mix everything like Lego pieces in DSL. This is nice. So if you mix them together, you create a new concept that's called lambda with receiver. Let's see this scenario. So you have a function here that you apply something to a string. The string is WAES, and you apply something in return. And you see here, this is a lambda function inside another function. So I see the high order. And then I'm passing an anonymous parameter called name, which is the name. And then I'm finally doing the uppercase function inside to get it in uppercase. OK. What if I want to turn it more readable for humans? Removing num invocations. So I can do this because with lambda with receiver, we can make the context more understandable. So even a function being passed by parameter can be an extension of a string. So it means that if you read the code here, WAES, apply something, then return, and that I'm just printing an uppercase. You see how it's easy to read than doing a lot of stuff like arrows and declaring variables and animal variables and referring them. So this is also a nice feature if you want to get a fluent code. And as I said before, we have so much more features inside that. Yeah, so now I will show you a quick example about how can we use a DSL in a real life. For this, I created a scenario here. As I work at KLM, so I created this Spartan airport. Yeah, you see this line? This line is an airport. It's not so beautiful because I'm backend engineer. I'm not front-end, so please take it easy with me. Yeah, but imagine that you have an airport, and inside that you will receive, and you need to track all the airplanes and the passengers inside that. So, for instance, you receive a 777, and then you have the passengers to be tracked in the departure station. You have a different airplane, like an Airbus, and you also have to track these informations. We have now an extraterritorial plane also, but you don't need to track it, but you need to show what is the third-party airplane. And another simple example. So what I will do here is open my presentation, my project, sorry, just a second. Well, so yeah, here you can see data code. I have a code here who basically prints the airplanes I have in my airport context. So you see here an ASCII art with the passengers I currently have. So 251 passengers, third party, I don't need to track the passengers inside, and also Airbus here. So if you look the code, I have two examples. In the left side, I have a regular example of this, of a Kotlin project, and the right side, the DSL build. So in the left side, you see airport being initialized like a simple object called object, and it has inside a property, which is a collection of airplanes. And after initialize all the airplanes, I am adding the airplanes to this collection of inside the airport. You see in this code that everything is verbose because you are repeating the words. You are doing things like using equals to initialize variables, and you are manipulating them. So this is a simple example, and then we can see that it's not so readable for human. If you ask your mother or your sister that it doesn't work with programming and try to explain, she will be hard. It will be a hard thing to do. But if you look to the right side over here, what I have is similar to a JSON object. You see, I created a mini language inside Kotlin to facilitate the process to understand everything. So you see an airport and curly braces. And what I'm adding to this airport? Well, I'm adding a 777, a third party. I don't need to invoke a function. I don't need to refer that to an object. I just need to call a third party. It's very simple. And you can do that in a different scenarios. For instance, if the end of my process, I want to add a new 777, I just have to write a new 777. Well, now I have a new 777. I don't need to add it to the collection of airports because it does it for me automatically. And how it works? Well, I will open the class of extension functions I created. Yeah, it's open already. Yeah, over here. So if you see to the right side, what I have for the airport is just lambda with receiver because I have the type airport with a lambda passing being inside the parameter. And I'm repeating this behavior to all the airplanes. So I'm applying functions to initialize the parameters inside them and passing them inside a lambda function, but as extension. So I'm applying the three features I mentioned for you at the same time, and then I create the new language. But imagine if you have all of the features together. Well, you can write just a text, something like a text. I'm not being a liar for you. You can just write a text, and everyone will understand that. That's really nice. Let me go back to the presentation. Yes. Well, but you have the DSLs, but something is strange, right? Everything is too good. I don't have like opposite points. I don't have things in bad to think about it. Well, actually, we have risks to add DSL. It's not just a cool thing that we can add in every project, in every necessity. If you want to add DSL, the first thing to do is to understand your context, understand your business domain, because it really have to make sense to be added. I cannot add a DSL into a try-catch, for instance, because it doesn't make sense. Try-catch is just an incidental complexity code. I don't have business inside that. I don't have reason to build a DSL. If I spend my time doing that without necessity, I can fail in a sprint delivery, for instance. So because DSL takes a long time to be built, you have to be patient because you have to think on all of kind of stuff to simplify the code for those who will read that later, basically. Yeah, so these are the risks. So if you have some questions, you can write that on YouTube. I will take my smartphone here and I can read for you. Just a second. Yeah, so let's see if we have questions right now. You have questions?
Yes. In the meantime,
okay.
People can ask the question. First of all, thanks. But the question is, did you already use this in one of your projects at WAES or at your previous experience?
Yes, I added a DSL wrongly in my previous project. It was not good because, yeah, I tried to, when I discovered the DSL functionality, I tried to add it in my project, and I realized that I spent a lot of time to build that. And that's why I put the risk slides for you all. So yeah, take care when you add the DSL. But currently, in the KLM, we are working on a project that we have to modernize systems, and then DSL are being studied to be added as well, in order to facilitate, because if we have to focus on maintainability, so this is a good approach.
Okay, cool. Because speaking about the risk, because what is a good sign to start with it? Because yeah, maybe people are thinking, okay, you say it has huge advantages, but not on every project. So what is a good sign for people that can use it?
Yes, a perfect scenario to start using the DSL is where you need when you have a complex domain to be understandable. So using the DSL is basically the solid state of the DDD. So after a DSL, a person who works as a business process analyst can read the code for you. And that's nice, because you have a nice purpose. You have to spend time to have an understandable code. I have a question here from Rodrigo Tato. He asked me how DSLs and DDD could work together. Yes, DDD is a design pattern. You use DDD to identify what is your business logic, what is your domain, and then you start developing under it. It's important because you have a north line to follow. And with DSL, you can make the abstraction, which is the DDD, you can make this abstraction visible for everyone, because you are constructing a DSL after a DDD definition. So have the graphs and then the code, and the code reflects the graph. So it makes it easy for everyone to read and understand your context at all. Well, yeah, that's it. Rick said, who is excited to JP. Yeah, everyone wants to see the fight.
Cool.
Yeah, that's it, guys. I hope you liked that.
Thanks.
If you have more questions, you can enter to WAES website or ask us for in the DM. Also, we will provide you answers.
Thanks, Igor. Well, the second presentation of this tech talk is from our colleague JP. He's going to talk about our fight. And yeah, I think everybody loves to fight once in a while to watch. So we're going to see a fight regarding JVM frameworks. And we are going to talk in the red corner will be the Spring framework, and in the blue corner, the challenger will be Micronaut. So I'm really curious what the fight will look like. I will give the floor to you.
Thank you.
Welcome.
Thank you very much. So let's just change the presentation here. Okay. Yep. Okay, here. Okay, cool. So as we can see here, I'm gonna talk about Spring versus Micronaut. So as Herod said, so it's not it's not going to be just a comparison between them, but it's going to be like a fight. But first, let me introduce myself. So my name is João Paulo, but you can call me JP. I'm a Brazilian living here in the Netherlands since March of this year. I'm a WAES software engineer working at Rabobank. Rabobank is one of the biggest banks here in the Netherlands. In my spare time, I like riding my bicycle, cooking, eating, and watching movies and series with my wife, Ingrid. And here in this image, let's get the pointer here. So you can see my cat. His name is Brie. And he's not that size anymore, so he's a little bigger now. But yeah, and you can see that I really like to eat because his name is Brie, so like the cheese, so yeah. So let's continue. So yeah, so this presentation is formatted like a fight between two opponents. So instead of just comparing them, we will throw them in a mortal combat. So yeah, this is the idea here. So in the part one, I'm going to introduce the fighters, just talk a little bit about the context and the history of them. In part two, in the moves list, so we are going to see some features and compare them. Part three, we are going to have this performance comparison. Then in part four, we are going to talk a little bit about ahead of time compilation. So this is a new feature of Gradle VM. And in the last part, the part 5, we will see who is the winner. So let's start. Just a small disclaimer. So despite this presentation is formatted like a fight, so you don't need to worry because no frameworks were harmed in the making of this presentation. So yeah. Okay, so to start, a little question. So what's your favorite Java framework? So you can read the QR codes or just go to maintainable.com and type this code here. So let's just wait some seconds because we have this small delay. Let's go to the page. Here. Okay, I just need to put it bigger. Okay, cool. Yes, so as expected, Spring is the biggest one here. 10 people answered, okay, more people. Microprofile, nice. Okay, so yeah, so we have some answers already, so nice. So Spring is the most lovable one, so yeah, let's see what's gonna happen in this fight. So let's go back to this presentation. Okay, so let's introduce our fighters. And here, so the idea is to just give some history. But first, let's open this parenthesis here. So just to clarify the difference between Spring and Spring Boot. So Spring is this application framework with this dependency injection container. And Spring Boot is one module of Spring. And you can use Spring Boot to create standalone web applications. So this is the main difference, just to make it clear. Now, so Spring was born almost 20 years ago. And it was released in this era where it was a little harder to create Java web applications because you had to configure a lot of XML files and other stuff. So Spring Boot in 2014 was released, and it has this philosophy that use convention over configuration. So the main goal here is to boost the developer productivity. So it's a really nice framework. And the Micronaut in the right side here was released in 2018. So it's really younger when we compare with Spring. And the Micronaut was released in this era of cloud native stuff and microservices. So yes, it's a really different era here. So the language that they support, so both support the same language, so Java, Kotlin, and Groovy. And Micronaut has a Scala in its roadmap, but we don't know when it's going to be released yet, but it is there. So if you love Scala, maybe one day you can also use Scala with your Micronaut application. Okay, so here is where is the biggest difference between both frameworks. So Spring does the dependency injection at runtime, and Micronaut does the dependency injection at compile time. So this is why, just a small spoiler, we'll see in the next slides that Micronaut is better in the memory usage and also in the startup time. So yeah, but just a small spoiler. Let's skip for the next slide. So, and there is also another difference here. So Micronaut uses the JSR 330 annotations instead of the ones that we are used to in Spring. So what is this difference? So in Spring, we are used to use auto-wired. So in Micronaut, it's called @inject. Spring uses the @component or @service or @repository, for example. And in Micronaut, you can use the singleton. So the result is going to be the same. And another nice feature that is the ahead of time compilation. So this is the new feature of Gradle VM. We will talk more in details in the next slide, but just to be aware, so Spring has one project called Spring Native, but is still experimental, but they are developing it to support the ahead of time compilation. And Micronaut is already ready to the ahead of time compilation. So here we can see a chart comparing both a lot of frameworks. So this is a survey. So they asked which framework are you using. And as we can see in the left part, Spring Boot and Spring MVC are the most used ones. Micronaut has 5% in this survey. It's not that much, but if we look at the right part of the chart, we can see Play Framework, Grails. They are much older than Micronaut, and they are in 3% use. So yes, it's quite expressive for a new framework already to have 5%. And we also can see Quarkus with 11%, so much bigger than Micronaut. But the focus here is Spring and Micronaut. So let's compare some features. So we call it moves list. So the first move is, well, not this one, but if you know what it means, probably you are older than 30 years or you have had a nice childhood. So yes, let's just go to the next one. So before in comparing the features in the code, so let's just put some context here. So in the code that I'm going to show to you, I create a kind of a microservice. So it's a food order application. We are going to use the Kotlin as well. And we are going to create some APIs, consume some APIs, and also talk to a relational database to put some information there and also to read some information. So let's see the code here. Where is it? Okay, here. Cool. So here in the left part is the Spring code, and in the right side we have the Micronaut code. So as we can see, the code looks almost the same. So here we have an annotation. In Spring, it's called REST controller. In Micronaut, it's called only controller. Here is the constructor of this class called order controller, and we are receiving the order repository using the dependency injection. And here it works the same way. We also have it here. Okay, my mouse is not working anymore. Okay, now it is. Cool. Yeah. Nice. Okay, so as you can see here, so the annotation is different. Here also the annotation is different. So in Spring it's called get mapping. Here is called get. And here the class is also different. So in Spring we are used to a response entity, and here is HTTP response. But here inside this function, the code is almost the same. And if you go to the next API, so this is get mapping to get an order by ID. It's almost the same code. So we are calling the repository here. We are checking if it's empty, so we are returning not found, and here, yeah, looks like the same. But if we scroll a little bit to the bottom, we can see one difference here. So the order DTO. So in Micronaut, we have this annotation called @introspected, and what it means. So as we saw in the first slides, Micronaut does the dependency injection and other stuff as well at compile time. So Micronaut does not use reflection to do its magic. So because of that, it's a little faster than Spring. So we need to give a hint to the compiler that we need to introspect this class, so that we need the metadata of this class here to be used. So why do we need that? Because here we are returning this class, and to be converted to JSON by the JSON, we need this introspected here so it can do its magic. So, okay, so here is the way to create an API. And in the next class is, so as I said before, we are creating this microservice as a fully ordered application. And this is the way to call an external API in Spring. So here we are receiving a postal code. So imagine that you are creating this API to receive the orders, and you need a postal code to receive an address. So here is the way to do that using REST templates. Of course, with Spring, you can also use something like the non-blocking way, so the Spring Webflux as well. It's also possible, but you need to add a new dependency into your project. And in Micronaut, there is one way to do that, is this declarative way. So you just have this interface with some annotation. So here is the base URL. Here is a get annotation saying, okay, I want to get something from this path here. And this is going to be implemented at compile time for you as well. So the performance is going to be great. But of course, if you have a complex scenario and you also want to do something similar that you do in Spring Framework, we have this low-level client here. So it's looks like it's almost the same here. And here we can see one difference that I was talking about. So here it's singleton, and here it's at service. And yeah, here the code looks almost the same. So we are just receiving the HTTP client here, and we are creating a request and just retrieving the information. And by default, Micronaut is reactive and non-blocking. Because of that, it's returning a publisher here. Of course, with Spring, we can do the same, but we need to add a new dependency here to have the same behavior. So now let's talk a little bit about the relational database. So in Spring, we are used to use the CRUD repository, for example, as we can see here. And in Micronaut, here, I think. Let's close one so I can access. Yeah, so here. So as you can see, the code is the same. So we can see only the differences here because we are importing from the different locations. But yeah, the notation is the same. The interface here is the same. So everything is the same. But there is a huge difference that we are going to see in the performance comparison, because Micronaut is doing the implementation of this interface at compile time. And there is another advantage doing that. So for example, if you are building an invalid query here, Micronaut is going to tell you at compile time that you have a problem, so you don't need to run your application to see the problem happening, like in a Spring Framework. So yes, it's a nice difference here to point. So let's go back to the presentation. Yeah. Okay, cool. So here we have other features to compare in both frameworks. The first one is the MongoDB repository. So in both, you have this implementation. In Micronaut, I think it is maybe 4 or 6 months old, so it's a new feature. Redis repository, we do have it in Spring, but we don't have it in Micronaut. But of course, you can use Redis in Micronaut, but maybe you can import the Lettuce dependency, and you will need to write more code, but it's going to work. It's possible. Kotlin coroutine. So I'm also a Kotlin developer, and coroutines are awesome, and both frameworks support Kotlin coroutines. AWS Lambda, so if you want to create your serverless application, you can use both frameworks for that. Messaging, so Apache Kafka and RabbitMQ are also supported. And another important feature, so the micrometer. So nowadays we are working more with microservices, and it's really important to have the monitoring of your application. And the micrometer works almost the same in both frameworks. Okay, so next part. So it's the comparison, the performance comparison. So here we will see some differences in the frameworks. So the first nice thing here is the startup time. So microservices running in Kubernetes clusters. So you have these auto-scaling policies. So imagine that you have this advertisement on TV. So more users are coming to your application. So you need to scale it fast so you can deliver our content to all the users. So having this startup time lower is better in this situation. And we can see here the time in seconds for Spring Boot. This is only a Hello World application. So it's 6 seconds versus 3.5 seconds. And Spring has these characteristics. So when you are adding more classes with the annotations at service or at the repository, so the startup time is going to be even bigger because Spring is doing stuff at runtime for you. So yeah, this is something. The next thing is the memory usage. So Micronaut is doing a lot of stuff at compile time, and it reflects here. So we have this advantage of using less memory, and for your company is good because you are going to pay less money for your cloud provider. So it's a nice feature. What else here? Okay, the jar size. So it's very common to put your jar in a Docker container and store it somewhere for some time. So here, it's half of the size for this Hello World application. So you are also going to save money for your company using Micronaut. So yeah, because smaller is better. So yeah, so it was 3 in a row. So if you also know what it means, so yes, nice. Okay, so of course, doing a lot of stuff at compile time has its cost. So the compilation time in Micronaut is worse than Spring Boot, but here we are talking about some seconds more. So I think it's a fair price to pay to have the advantage that we saw in the previous slides. Okay, so remember that code. So the repository in Micronaut and in Spring looks the same. So the code is the same, but here we can see a huge difference. So because Micronaut is doing its job at compile time, so it's more, the performance is better here. So we can see that Spring Data JDBC can do 275,000 operations per second, and Micronaut can do 430,000. So yes, it's a huge difference. So another point for Micronaut. So, okay, so in the next part, I'm gonna talk a little bit about ahead of time compilation. So this is a new feature of GraalVM. I'm not gonna go into details about GraalVM. I'm just focusing in this specific feature that is the ahead of time compilation. So, but before talking about ahead of time compilation, let's talk how it works when you are not using ahead of time compilation. So you are using the just-in-time compilation. So you have your code, so it can be Java, Kotlin, Groovy, or Scala. So when you compile using the C1 compiler, it's gonna create your bytecode, so probably a jar file with a lot of bytecodes there. Then you deploy your application to production, it starts running, so the JVM is gonna see what's happening inside your application, and the code that is being more accessed is gonna be compiled to native code. So they call it the hotspots of your application. So because of that, when it happens, so your Java application can be as fast as a C application, for example, because we are also compiling to native code here with a lot of optimizations because the JVM is watching your application live. So yeah, this is a really nice feature. And when we are talking about ahead of time compilations, so after having the bytecodes, we can compile it to a specific platform. So Java says that you can write once and run everywhere, but when you are using ahead of time compilation, this is not true anymore because you are targeting a specific platform. But of course, there is a thing here to know. So the compilation to native code takes a lot of time. So I did this small Hello World application, and it took more than 5 minutes to compile to native code, and it's a very memory intensive operation. So yes, so it's nice to be aware of that, because if you, okay, I'm going to use ahead of time compilation in everything, so it's not a good idea because probably your pipeline is gonna get stuck. So you can bring some problems for your company. And the other thing that happens, so because in the just-in-time compilation, we have the JVM watching your application, so it can do much more optimizations for you. And here, the compiler don't know how your application behaves, so you don't have that many optimizations when your application is running. But of course, there is one scenario that I think it's nice to use, this ahead of time compilation. So with serverless applications, because serverless applications are normally small, and also the startup time is really important. And when your application is compiled to native code, so it's almost instantaneous to start your application. Is a really good scenario to use that. And talking about Micronaut and Spring, so Spring has its project called Spring Native, so it's not production ready yet. And with Micronaut, you can just create your serverless application and deploy to AWS or Azure or Google, and it's gonna work fine. So yeah. Okay, so who is the winner? So let's go to the most expected part of this presentation. So, but of course, we are talking about tools. So a hammer can be good for one scenario, a screwdriver for another scenario. So yes, to be fair here, let's put a scenario first. So if you want to build a microservices, you will need to expose some APIs, also consume some third-party APIs. If you are using a relational database or even MongoDB, can be as well. If you need to send metrics for some monitoring system and also logging. So this is the scenario that we are going to compare them. So yes, so now we have the scenario. So we are going to see the criteria that we are going to compare them. So the first one is the features. So Spring Framework is much older, so it has much more features than Micronaut. So this time Spring is gonna punch Micronaut. So we can see in the bar there that, yeah, it's not that good. And the next criteria is the startup time. So as we saw in this presentation, so Micronaut is better, so it's fighting back. Next one is the jar size. So again, Micronaut is better, so you can save money storing less things in your. So again, Spring is getting hit. Next time is the memory usage. So again, Micronaut is better. So toasty again. Next one, so Micronaut has this declarative HTTP client that is really nice and it works really well, so it's much easier to use. So another hit here. So Spring, yeah, not that good. Just to return here, so of course you can do the same thing with Spring if you use an external dependency, but here it's already inside the Micronaut, so because of that, yeah, I think that Micronaut is better. JDBC data repository, we saw that the difference is huge. So again, so Spring is, yeah, Micronaut wins this battle. So don't be sad because it's just a joke, of course. So both tools are really great, and Spring has this history of almost 20 years helping us to boost our developer productivity. But yes, so but in this case, I think Micronaut is better. So thank you very much. If you wanted to talk a little bit more about the framework, so you can contact me on my Twitter account. So yes, I will be happy to answer your questions. And do we have any questions here?
Yes, definitely. Thanks, first of all. Thanks.
Thank you.
The first question is from Felipe. Have you looked into Quarkus, if I pronounce it correctly?
Yeah.
If so, what do you think of it? I expect it to be really comparable to Micronaut.
Yeah, so I think it can be even better than Micronaut in some scenarios, but I didn't study it deeper than like I did here. So maybe we can make a new presentation with both.
Could be a good idea.
Yeah.
Felipe asks, Felipe Montero asks, does Micronaut have the same support for units and end-to-end test as Spring have?
Yeah, so you can also use almost the same tools in both frameworks. So yes, it has.
Okay. Another question, do you think, because Spring is still way bigger, do you think in the following years that Micronaut will be have more usage if you compare it to now?
Okay, so I don't think so, because Spring is already doing some more work. So they are building this Spring native project. So they are trying to be as good as Micronaut. But of course, while they are working, Micronaut is gaining some market share. So I don't think Micronaut is going to be as big as Spring, but will be their share in the market.
You're going to well.
Yeah.
Okay.
Yeah.
Cool. Let's check if you have any more questions. From Tato, is it possible that Spring and Micronaut work at the same time in a project, thinking about migration from one framework to the other?
Well, it's possible to put some Spring features inside Micronaut, but if you want to migrate from Spring to Micronaut, you need to do a big bang. So you need to create a new microservice, I think, to have all the advantages that we saw here. So yeah, it's not possible.
Okay. Cool. Any more questions? Cool. Then I would like to ask Igor as well to stage.
Oh.
Thank you, guys. It's a huge surprise what's in there, of course.
Okay, thank you
There
very
you
much.
go. Thanks for the awesome tech talk.
Thank you very much.
Thanks.
Thank you.
And indeed, thanks. If anybody got questions, feel free to do it by Twitter or by email, or just get in touch with us, because I think it's good to answer your questions if you still have them. For now, thanks for watching, and have a good evening. Bye-bye.